This is the UNCC Senior Design 1 project, infrastructure design for a CESA multiplex container laboratory, in partnership with Global Stratus. The objective of this project was to design the infrastructure for a mobile, off-the-grid laboratory and buy center where clients can sell commodities. Lab workers use the lab to analyze goods and use Commodity Co, Global Stratus real-time trade value software, to provide a fair offer to the clients.
Project requirements. The lab and buy center need to fit inside a standard size shipping container. The container needs to be easily moved and assembled quickly. We also need to provide infrastructure for the systems discussed in the design section of the poster.
The layout is designed for a container with swing doors at both ends. End walls will be made just inside of the container doors at both ends of the container, so that the inside of the container is blocked off when the swing doors are open. Entrance into the container will be through access doors mounted on the end walls. The lab has two main areas, a commercial area and a laboratory area. The commercial area has two buy center cubicles for clients with an access door and counter, a buy center counter where lab operators will serve clients, and a product processing area where products will be assayed and precious metals will be smelted using the induction furnace. The laboratory area will be used by lab operators to perform environmental analysis and other lab functions. It will have counters with upper and lower cabinets, a sink with potable, hot, and cold running water, a server rack and tablet charging station, as well as an access door on the end wall.
The lab will be equipped with an HVAC system to keep the interior at a bearable temperature with the help of insulation, as well as an exhaust hood to extract heat generated by the induction furnace. The lab will also have an air filtration system to keep the air clean.
We have CCTV cameras, biometric and card access doors, bulletproof exchange boxes and viewing windows, and a depository safe for precious metals. We are monitoring other aspects of the lab with custom sensors and server software. Data is viewed remotely with the GUI we made. And we also designed infrastructure for receiving and broadcasting internet and a local area net around the lab.
A 10 kilowatt PV array will provide power to the lab and create a roofed-in area in front of the container. Power will be managed by an Outback rating inverter system that will provide up to 32 kilowatts of power. This system can be expanded to provide up to 80 kilowatts of power if needed.
Water system. Potable water will be provided to the lab for drinking and analyzing minerals, and it will be obtained locally. A filtration system will be implemented to filter 250 gallons per day. Wastewater will be stored, filtered, and reused on site.
For future plans, next semester will include finalizing design changes for the container to create a full CAD render and 3D model of the project, as well as a mock-up of the project using a rented full-size container to provide a visual representation of the layout. This concludes our presentation.